So one of the really nice things about the Angular router is that the URL isn't broken up into a linear collection of segments, but rather a tree of segments, and each of these tree segments can contain its own route parameters. So for example, I have a detail here in my primary outlet called primary ID, and then I have a secondary outlet that contains its own detail that has a parameter called secondary ID, and a tertiary output that has its own parameter called tertiary ID. And the great thing about the Angular router is that it creates very tight cohesion between the parameters and the activated route segments, such that when you're inside of a view component, you can inject the activated route instance and get access to this particular parameter. So from a local standpoint, it's really wonderful to work with. From an external or a global standpoint, it makes a URL a lot harder to work with because there's no single place where I can just grab, say, the tertiary ID or the secondary ID. Instead, what I have to do is walk down through the current router state URL tree and look at the param collections for each of the segments, and then collect those into a single location. And this isn't necessarily something you have to do a lot, and you could argue that it's not necessarily the quote-unquote Angular way, but it's certainly possible, and it's something that I've been asked for several times, so I wanted to put together a quick demo. In order to encapsulate this logic, I created a router params service, and this router params service is going to expose a RxJS observable called params, and that params observable is going to emit a value every time the global aggregate of route parameters changes. And then I'm just going to expose that as a snapshot as well, so you don't have to subscribe to it necessarily. Now, internally, what's going to happen is that we're going to subscribe to the router events, because the router will emit events as the state changes, and it will emit a navigation end event when the URL navigation is successful, at which point we should be left with a URL state that contains or may contain updated URL route parameters. I say may contain because there are other reasons that an event can be fired, such as a change to the query string, in which case the route parameters may not change. So every time a navigation end fires, we're going to grab a snapshot of the router state. We're going to collect the parameters on that router snapshot. And if we jump down here, what you can see essentially is that we iterate over the URL tree I alluded to before. So we start with the root. We grab the parameters that are in the root, we assign them to this aggregation. Then we look at the children of the current place in the URL tree, and we iterate over each one of those children and recursively call the same method. So essentially what we're doing is we're doing a breadth, no, I guess it would be a depth first. We're doing a depth first walk of the URL tree, finding all of the individual nodes, grabbing all of the parameters from those individual nodes, moving them into a given aggregate. We're going to return that aggregate, and you can see if the aggregate is different from the previous aggregate, then we go ahead and we emit that on that RxJS observable. So in our app component, what we can do is then inject that route params service that we just created. We can subscribe to the params object on that, and in this case, I'm just going to grab that params and we're going to render it in the page using the JSON pipe. So let's take a look at this in action. So here is my Angular application, and here are my secondary and primary router outlets. And you can see, let me close some of these. If I go to this one, you see we have 101 in the URL, which is my primary ID, and you can see that's now showing up in that global params object. And then if I go to, say, my secondary and I go to 202, you can see down here in the console, I'm logging in out because the URL gets a bit long. We have primary ID 101, secondary 202, and of course if I go to tertiary and go 303, we can see that tertiary now has a value of 303. And of course I can back out of some of these, so now we only have primary and tertiary, and I can back out of the tertiary one, and you can see that now I only have primary, and of course I can go home. And I could go to any of these individually, right? I could just do just tertiary, or I could do, let's just say, just secondary. So essentially, again, what we're doing is we're watching the router state, and every time the router state changes, we are listening for that navigation end event. At the navigation end event, we're walking through the router state, the URL tree associated with the current router state. We're collecting the params from each individual segment. We're aggregating those in a object, and then we're emitting that object as part of this router params service, which we then take and we dump into the page as JSON. Now, one of the nice things about the high cohesion that the Angular router creates between the parameters and the activated route is that the names are local to the activated route. So of course you can have different activated routes that have a similarly named parameter, right? This could just be ID. In fact, all of these could just be called ID, which is fine when you're dealing locally with an activated route. But the moment we try to take all of those parameters and jam them into a single aggregate, we run into the chance of naming collisions. So just something to keep in mind, both when you name your parameters and also when you think about trying to aggregate them in a single location. But anyway, it's not something that I've really ever had to do, but certainly it's possible. And if nothing else, looking at the implementation of this can kind of give you a sense or a better sense of how the Angular router works and how the state of the URL is represented inside of the Angular router.